Hello students, welcome to chemistry classes. So in this video lesson we are going to discuss some chemical reactions of alkanes. So normally alkanes are inert with acids, bases, oxidizing and reducing agents. Alkanes are inert compounds with acids, whether it is strong acids or it is a weak acids, oxidizing agents or the reducing agents. But it undergoes some of the chemical reactions, especially substitution reaction. Substitution is an important reaction, can be carried out with the help of this alkanes. And also sulfonation, nitration also takes place. Nitration and sulfonation. Lower members of this alkanes is rarely undergoes sulfonation as well as nitration, but the substitution reaction is a common term. Normally the substitution reaction can be carried out in the presence of sunlight, or it is heated at the temperature range of 573 to 773 Kelvin, 573 to 773 Kelvins. Now we are going to discuss the pre-radical substitution reactions of methane. Methane reacts with chlorine in the presence of sunlight. Substitution reactions of methane. Here one of the hydrogen atom and here one chlorine atom are replaced. We get methyl chloride and hydrogen chloride. Once the methyl chloride is formed, it further reacts. Methyl chloride reacts with chlorine. In the presence of sunlight, it gives CH2Cl2 and HCl. Methylene chloride. Methylene chloride reacts with chlorine. In the presence of sunlight, gives chloroform and hydrochloric acid. Chloroform and hydrochloric acid. Chloroform. Chloroform is formed. Chloroform reacts with chlorine, gives carbon tetrachloride and hydrochloric acid. So these are the substitution products formed in the case of methane with chlorine, methyl chloride, methylene chloride, chloroform and carbon tetrachloride. Chloroform and carbon tetrachloride is a substitution reactions of methane. Ethane also reacts with chlorine, gives ethyl chloride. Ethane reacts with chlorine, gives ethyl chloride in the presence of sunlight. The rate of alkanes with halogens, rate of the reaction of alkanes with halogens in the order of fluorine, chlorine, bromine and iodine. So order, rate of the reaction towards alkanes. Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. The fluorine violently reacts. In the dark condition also react, but it is controlled. It's not easily controlled. Controlled condition, the fluoride compounds are obtained. Iodine is very slowly reacts and also it gives reversible nature. For example, methane reacts with iodine, it gives methyl iodide and hydrogen iodide. The methyl iodide and hydrogen iodide again reacts with react together to provide methane and iodine. So these are the substitution reactions. The substitution reactions not at all takes place in a single step, but it can be takes place in many steps. The various steps involving the pre-radical substitution reactions are chain initiation, chain propagation and chain termination process. In the initiation process, chlorine reacts with the sunlight, gives two chloride free radicals. Once the chloride free radicals are formed, it attacks the methane molecules to form methyl free radical and hydrogen free radicals. The methyl free radicals again reacts with the chlorine, gives methyl free radicals, chlorine and other ions. Finally, this two free radical, methyl free radical and chlorine free radicals are under the terminating steps provides methyl chloride. The second one is combustion reaction. So I already told you combustion reaction. Methane under controlled conditions on burning gives carbon dioxide and water. Carbon dioxide and water. Methane, combustion reaction of methane. Combustion reaction. Methane gas burning with oxygen gas gives carbon dioxide and water. Carbon dioxide and water. This is a higher alkane also. Higher alkane also burns with oxygen, gives carbon dioxide and water. So it provides, in addition to this compound, it provides larger amount of energy, so that these compounds are highly useful as a fuel. Incomplete combustion gives methane on incombustion combustion gives carbon solid and water. Carbon solid and water. So this is a component which is highly useful for filters. Okay. This is the second part, combustion reactions. The third reaction is controlled oxidation. These compounds are not easily undergoes oxidation, but the oxidation reaction can be carried out under controlled condition, gives different products. For example, methane on oxidation gives methyl alcohol in the presence of copper at 523 Kelvin. First of all, oxidation. Methane on oxidation in the presence of copper at 523 Kelvin, 100 atmospheric pressure, controlled condition, gives methyl alcohol as the product. Methyl alcohol as the product is the first reaction. In the similar way, methane on oxidation with molybdenum oxide. Methane on oxidation with molybdenum oxide gives methanol, that is formaldehyde as the product. Formaldehyde and what? Formaldehyde as the product. Methanol, formaldehyde as the product. Ethane on oxidation with manganese acetate. Ethane on oxidation with manganese acetate, CH3COO twice Mn. Manganese acetate gives acetic acid and acetic acid as the product. Acetic acid is a major product. So these are the controlled condition. Oxidation, methane on oxidation gives methyl alcohol, methane on oxidation gives formaldehyde or methanol, ethane on oxidation gives acetic acid and water. So these are oxidation reaction. And another one case, the ordinary alkanes, that is 2-methyl propane on oxidation with potassium permanganate gives tertiary butyl alcohol. 2-methyl propane. What is the formula for 2-methyl propane? CH3, CH3. This compound on oxidation with potassium permanganate gives tertiary butyl alcohol. 2-methyl-2-propan. Also one of the important conversion. How will you convert 2-methyl propane to 2-methyl propanol? 2-methyl-2-propanol. 2-methyl-2-propanol. This is 2-methyl propane. How will you convert 2-methyl propane to 2-methyl-2-propanol? It's a normal oxidation. So, these are first part of this chemical reactions. So far we discussed the three reactions. First one is this substitution reaction, free radical substitution reaction. Next, combustion reaction. Third, controlled oxidation reaction. So depends upon the nature of the oxidizing agent used, we are obtaining the different oxidation products. Okay. If you have any doubts, you may ask. Thank you.